We have been hearing a lot of buzz and confusion regarding the differences between prompt engineering, retrieval augmented generation, and fine tuning, what to use when. So this is a very simple example for even a school going person to understand how these things work and which one should you use for your specific application that is there. So just think about prompt engineering as a simple robot that is able to answer your questions that are there, and we will take it step by step as we go to the next slide. So what is basically a prompt engineering? Just think about it is a very basic type of robot that when you are crafting effective inputs for LLMs to guide the output without changing any model. Just take an example here. If a child is asking a robot a question, so better the instruction you will be giving, the better the answer it is going to have. So in this first case, there is no training involved. It is a low cost fast iteration, and it is very useful for capability exploration that is there. And here you can do lot of good prompt engineering skills, and you can mention it what type of way to act and how to behave. Like in this example, when a person is asking about gravity, then if you put the prompt that act as a physics teacher that is teaching to a 6-year-old and explaining gravity, then it is able to take in and explain in a good manner. So prompt engineering is good in some lot of use cases where you don't want very specific information and very specific knowledge that is there. Now moving to the next one, and I will be talking more about when to use what. Retrieval augmented generation. If you can see, the robot is having some books. It means that here the robot is just giving you answers from the large language model from all the data that is had. It does not have any external memory. But in retrieval augmented generation, if you can see, he is carrying book knowledge. So if you ask a specific question, like you're asking about physics or any specific research topic, he is not going to go to any LLMs, or he is not going to give you a vague answer. He is going to give you answer from the book that is there. So this is what is retrieval augmented generation. And when do we use retrieval augmented generation? When you need to combine these LLMs with external data sources, connecting it through vector databases and all those things that are there. And in this photo that I showed you, the robot with a backpack full of books, he retrieves the knowledge from these books before he is answering you something very specific. So there are a lot of complexities that go into compared to the previous prompt engineering. Here you introduced vector databases, so you have to convert the query to vectors, and then the database is also converted to vectors. Then there is a similarity match between the input query and the vector database, and then according to that context, they combine this context with the prompt and they generate a specific answer that is there. This is how retrieval augmented generation works in a very simple way. This is good for enterprise level applications, and 80% of the companies are relying on this because they want the data from their enterprise. They don't want the prompt to go away and get something very generic, very specific to that company. If you want something real time from your data, you want something dynamic, or you want something that is proprietary information about yourself. So this is what retrieval augmented generation works, and we'll be looking into different slides about comparing these things as well. Then the last third one is this something like Jarvis, right? The fine tuning. Here what we are doing is we are creating a special robot where we are telling it, we are fine tuning it by giving it more information, giving it more superpower, so that it is able to answer you specific questions in a specific manner. So here it is you are tuning and you're changing the whole design of this particular robot. So this is what fine tuning does. It changes the model completely for answering how it behaves and what it gives you as well. So this is what it does. It retrains the model, as you can see, and the metaphor that you saw, Jarvis is trained for a specific user, like for a specific user, Tom in this case, who adapts the behavior to that person's personal need that is there. So the robot now is customized to answer very specific for Tom or an enterprise. This is a metaphor for you guys to understand. Here it is an advanced version. It requires some domain specific data. It requires lot of money, as you know. Training this, fine tuning and training new LLMs create lot of high computational resources, lot of GPUs, and you need to do a complete fine tuning of the whole pipeline setup. There is a cost of GPUs as well as a training and a cost of the employee also running this. The education and the knowledge has to be much more. It is a little bit more complicated. Here you are going to have full control over the behavior, tone, and even the responses that are there. So this is what fine tuning does in a very simple way. So now what I want to do is I want to show you a table where we are comparing these things. As you can see in this table, when to use what, this is the confusion. If you hope you got a basic understanding of how these three things are different. And now for understanding about prompt engineering, we will first look into prompt engineering and the differences and when to use what, right? So in prompt engineering, custom data is not used, whereas in RAG and fine tuning it is used. Training needs in prompt engineering and RAG there is no training needs, whereas in fine tuning there is training need. And the custom data used for is there in RAG. It is not actually used for training, it is just used as a reference source for getting information, but in fine tuning it is using for internal fine tuning. Cost, prompt engineering is the cheapest and the easiest to start with. This is what I tell all my community members, AI residents, always try to start with prompt engineering. Most of the problems get solved there. If you want to go to RAG, you can do that. It is a cost becomes little medium, and fine tuning is very expensive, as I was mentioning. Flexibility, prompt engineering is little less flexible. RAG is a little bit more flexible. You can connect more documents and everything, but fine tuning it is a lot. You can change the behavior, you can change the data, you can do whatever it wants. Speed to deploy, nowadays everyone wants things faster, so speed to deploy is amazing. In prompt engineering you can do something within an hour. RAG depends on DB setup, but I recommend Pinecone, you can do it quicker. Fine tuning is time consuming because it's more not only about inferencing but also about time consuming that is there. Just to summarize all these things we have discussed, some real world applications. Prompt engineering is very good for prototyping, internal tools, creating quick POCs, creative usage, and all these marketing things that are there. Playing around, the first always start with prompt engineering, get your hands dirty, and then RAG is for your enterprise level application where you have proprietary data. Yesterday we did a workshop on HR enterprise bots, so this is very important, that connects to your legal company policies that are there, legal assistant and FAQ engines. Every department, as you know, they have an FAQ, so these RAG based applications are very good. Fine tuning is a very good for very specific use cases for companies who want sales bots, personal assistants. Why sales bot? Because how your company is talking to a specific agent, the way they is talking to the new client, because you need to fine tune your company's culture, data to these fine tuning models so that it behaves in such a manner that is there. So fine tuning is something that is important for customization. As you saw, the robot Jarvis was very specifically built for a particular company or for a particular person. So that is what fine tuning does. If you want to be the top 1 or 2% who are doing things very differently, and it is costly, and if it is really required, go for these type of use cases that you can do. So just again, some of the challenges that I wanted to speak about. Prompt engineering is trial and error heavy. This is the problem with prompt engineering. RAG needs vector database and indexing, so it's a level of learning as well as investments. Fine tuning is expensive, complex, and needs lot of redeployment that is there, which is not a faster option that is there. When to use what, as I mentioned you, prompt engineering for basic explanatory, RAG for domain specific, and fine tuning for branded voice, advanced personalization, and internal assistant that is there. So I hope you enjoyed this video, and remember this photo whenever people are talking about prompt engineering, RAG versus fine tuning. If you have not yet subscribed to our channel, please do that. We see that a lot of people view our channel but very few have subscribed. This will support us in creating more awareness videos to all of you. Thank you.